मैम आप लाइव हैं।
Oh, hello everyone, good evening. Welcome to our discussion forum. This is the second discussion on NPTEL course in Pharmacognosy and Phytochemistry. So last time we had discussed few queries from our learners. This time also for the remaining sessions as well as for the previous sessions, if any of you has any queries or need any clarification pertaining to the content, we are ready to discuss here on this particular forum. This week, we'll be starting with week 12. That's the ultimate week of our NPTEL course. And post that, we'll have one more discussion forum prior to the examinations. So, taking on few questions that were initially asked via a shared Excel sheet and a Google form. So, we have our learner asking us about how exactly flavonoids have been isolated. So flavonoids, depending upon their nature, occur in different plant parts. So they can be occurring somewhere in a very soft, fleshy part, like your fruit. They can be occurring in a very delicate part, like flower petals. Say, for example, your sophora flower petals. They can be occurring in your strawberries, as we discussed. You remember, fisetin is the one which occurs in strawberry. Sometimes they might occur in a little stubborn, what are called as the organelles or parts of plants, often as seeds as well as bark. So, depending upon the plant part and depending upon the moisture content of the plant, you can take a call. Mostly, what happens is if the glycoside occurs in the fleshy part, it's generally a water soluble glycoside, and sometimes if it is in the skin or a peel or in a bark, many a times it is formed in the or found in the form of glycodes. The solubility of flavonoid glycoside is much higher in polar solvents such as water, but equally soluble, or they are more soluble in alcohol. So as a result, if you observe, when we discussed our test for flavonoids, I suggested that you take ethanol or alcohol as a solvent, because no matter if your flavonoid is a glycol or a glycol, alcohol non-selectively or non-specifically also dissolves it. So if it is water as a solvent, there is a good chance you might purify a glycoside. And if it is a chloroform or very non-polar solvent, like an hexane, in hexane your flavonoids won't dissolve because they have polyhydroxy groups. But coming from chloroform, the few solubilities have been reported with respect to flavonoids that have less hydroxy groups. Coming to butanol, ethyl acetate, they are a preferred solvents for flavonoid glycones. And coming to alcohol and water, your glycones are more soluble in your alcohol, as well as when you see water, we generally don't prefer water as a solvent for glycones. Water is generally used for a solvent, or water is generally purified. Sorry, water is generally used as, or purified water is generally used as a solvent to extract flavonoid glycosides. So I hope that clarifies. Now, if you have stubborn plant part like your bark, it is very essential that you pulverize and soak it or give it more time to kind of imbibe that solvent. So extraction time required is much more, or you can do it at an elevated temperature. But while doing at an elevated temperature, just ensure that you don't encounter any hydrolysis or deterioration. Many a time your flavonoid glycosides are very stable, but if you are dealing with anthocyanins, anthocyanins are not stable to heat. In that case, you have to do maceration with a very polar solvent such as water. So that was one question raised on forum. Now another question was raised about the units of what is called as the angle or the degree of rotation, or what is called as optical activity. Now we say when you're discussing your compounds, especially volatile oils, L-menthol is optically active or sucrose is optically active. Now, this optical activity, we definitely agree, is expressed more in degrees. So, yes, you can have your answer in degrees, but the MCQs didn't feature degree as an option. It did feature a tricky answer, and that was milliradians. So, yes, if you go by the NIST list of standards for sucrose and for other compounds as well, milliradians as well as your degrees, both are acceptable in terms of your answers. Now, there are few questions on forum pertaining to the notes of the session. Again, we would like to apologize for the delay that's happening, but we are shortly coming up with the whole PDF of the notes, and you'll be able to download it under every week of this category. So you just need to get login into your NPTEL course, and under every week, the notes for this course or notes for those week will be available as the PDF version. We'll be following up, and we'll shortly be uploading those notes on the portal as well. So that takes care of majority of the queries that have been questioned or that have been asked about the notes part of it. There were few avid learners who were awaiting the certificate. Now the certificate is issued not on completion of course. The certificate is issued only when you are qualifying the examinations. So in your forum, you must have seen that there was a link for peering or registering for the examinations. So after you completed your internal assessment, that is your weekly assessment that you do on the daily basis, plus your end examinations, and if you're qualifying with the passing criteria, only in that case the certificate will be issued. Just listening or completing the course will not ensure you certification. So definitely that will gain you in knowledge, but for those aspiring for certificates, for those aspiring for transfer of credit points, in that case, what we have to do is we have to register for examination. Once you complete the examination, within a few weeks, the results of the examinations are out, and based on the outcome, you will be awarded the certificate, which will be or which can be downloaded as a PDF from the Swayam portal itself. Does that clarify? Any other questions from your end? We are very happy to take on this discussion forum. We'll await that for some time. There's also a question from a avid learner: is guar bean same as guar gum? So yes, guar gum comes or is extracted or is prepared from the seeds which are present inside the guar pod. So when you're consuming guar as a vegetable, or when you're consuming guar as in its entirety, you're also eating up the pod shell. But when you're purifying your guar gum, exactly what happens is, if you remember our carbohydrate sweet, there we said the carbohydrate is especially extracted from the inner part of seed, which kind of takes in the endosperm part. So the endosperm is taken, it is pulverized, and your guar gum comes in from that particular portion. So when you're comparing, is it same or is it not? In that case, the answer is it is not the same. Your guar gum is more of a carbohydrate, whereas your guar in its entirety will contain chlorophyll. It will contain your flavonoids. It will contain your other matter like your cellulose, proteins, allurones, and even the seed coats. So a lot of your what is called as fibers are also present along with the guar. Now just checking few more questions on the discussion forum. There was a question asked, are gums really water soluble? I get your questions because definitely gums, when they imbibe water, they don't form a very clear solution as your mucilages. So if you see your okra, that is your bindi, it forms a very clear slimy mucilage as well as your alginates or agars. But when you're discussing Acacia tragacanthum, now this point we say it is soluble from the Indian pharmacopoeia perspective. So if you see the monographs of this gum from Indian pharmacopoeia, you say that many of the gums, when you see their water soluble extractive value, that indicates that majority of them are water soluble. Not only that, when you see the quality control of them in your Indian pharmacopoeia, they say you can to solubilize 1 gram of drug, say for example acacia, in about 100 ml of water and filter. Now when you're filtering, we obviously call this as a soluble matter. So it says that after filtration, absolutely nothing or few milligrams or not more than 0.5% should remain on the filter paper. In that context, definitely we can call our gums as water soluble. So they are swellable, and where beyond a particular dilution, they form a very good soluble mixture which can be filtered through your G2 or G3 funnels. And that's the reason we call it as soluble or water soluble gums. Just a few more questions in the forum that are there. Okay, we have a learner asking us about the composition, especially of oils, that is the essential oils. And he wants to know the compositions of eucalyptus and how they are identified and how you can get those information. So, Saurabh, what happens here in is when you have essential oils, it is generally this oil, say for example, eucalyptus oil. What we can do there is we can take the leaves and do what is called as Clevenger-based extraction, which is more of a hydrodistillation. If you have them in a higher quantities, you can even go for steam distillation. Once you steam distill it, you will get little quantity of what is called as volatile oil which distills off. Now, this volatile oil, considering the current scenario, we can directly take it, dilute it in a suitable solvent. As you've seen in week 11, you have gas chromatography, which can be used for your essential oils. So we can take this, dilute it in a little bit of solvent like your hexane, and then inject it into a GC, which is coupled to a mass, that is GCMS. Now, what happens here is your eucalyptus oil, because it is a composition or it is a blend of numerous compounds in your GC, depending upon which column that you use, your different components will get segregated. Now, once these components are segregated, then they are inserted via a hyphenated transfer to a mass spectrophotometer. We call it as a GCMS. So when these peaks which are coming in your GC go into mass, they show the molecular weight. Now many a times these are monoterpenes or phenylpropanoids, and are there good chances that they undergo rearrangement, as well as there are good chances of deterioration. So the good part of the story is now this MS comes on with a built-in library. Now we have the NIST library, NIST library. We have the Melton library. Now we have Enzymine library. So depending upon this are kind of paid packages. So many institute purchase these paid packages. So your raw data of mass. So this is my mass fragment saying 189 molecular weight. They might undergo further fragmentation to do MSMS. So they will see the mass fragment, they will see the MSMS fragment, and depending upon the fragmentation pattern, identify the molecule. Not only that, due to machine learning, now there is also a phylogenetic search to it. So depending upon which plant, which kingdom you are having this plant, The AI ML interface will also help you support, and all the compounds, almost 98 to 99% of the compounds in your oil nowadays can be identified. Only that little 0.5% are written or are kept as unidentified substances. So you will definitely know how much percentage of which compounds are there in your sample. Just checking few more questions in the forum. Many of you are asking for your textbook references. So we have a lot of textbooks in pharmacognosy that are available online in PDF as well as hard copies. So we do have Trees and Events. We do have Pharmacognosy by Biren Shah. We have Pharmacognosy by Gokhale Kokate Purohit. We have Pharmacognosy by Tyler, and numerous other books in pharmacognosy that you can refer to. There are numerous good quality texts which are definitely beyond our syllabus which we have covered, but for your knowledge and with interest in pharmacognosy, I expect you all go through them also so you can get in-depth knowledge of what we have covered over a period of all these 12 weeks. We have a few avid learners asking about for the presentation, that is the PPTs. Unfortunately, we won't be able to share the PPTs for the course, but yes, we will be sharing the PDF of the lecture transcripts of the course. So definitely those along with the textbook I have suggested as an answer to the previous question. If you combine both, it will be very comfortable for you to understand and comprehend the syllabus of this course. You can feel free to put in any questions or provide any your request for clarifications with respect to the matter. There's a question about what are tannins. I think there's a typo and it essentially means what are tannins. So if you go by week 4, tannins are basically those compounds which have a ability to tan our skin. They are polyphenolic, but yes, there are some tannins which are called as pseudotannins because of their low molecular weight cannot have the ability or do not have the ability to tan our skin. So that's the little shorter way, but yes, do recheck the lecture notes for week 4 on tannins and you will get the answers to it. There's also a question from Rajesh asking, is Silimarin a natural product? Yes, definitely Silimarin is a natural product and it's a blend of compounds as discussed. And many a times you take the plant extract and call it to be Silimarin because the plant extract, essentially the purified and the fractionated extract, contains the set of all these three compounds. Now, in addition to that, nowadays, even synthetic blends of these compounds have been made available through laboratory procedures, and both of them, but seeing the market as far as the hepatoprotective activity of these compounds exists, both the synthetic blends as well as the natural blends of these compounds are available in market. So any more for or any more questions from the learners who have joined online? Please help us. If you have any queries, put it forward. We'll be happy to answer. We just wait for 5 additional minutes. If there are no additional questions, we'll close the session for today. So, dear learners, if you have any questions, please share them in the chat box. We'll await for another 5 minutes before we close the session for today. So going to the next question, and that is Rajesh's question. What is the simple procedure to isolate flavonoids? The simple procedure to isolate flavonoids again depends on the concentration of flavonoids, preliminary, concentration of interfering impurities, what plant part it is. Say, for example, if you're talking about flavonoids such as rutin, which are there in your sophora flowers to the extent of 20%, you can easily do an alcoholic extraction followed by precipitating this concentrated alcoholic extract in your water. So when you pour it in the water, there's a good chance that all the water soluble impurities will precipitate out. And predominantly, since the flower contains almost 20% flavonoids, you will see more of this alcohol soluble matter is generally flavonoids. So you might get a precipitate which is more than 80% plus flavonoid, that is your routine. You can just do a simple recrystallization and you will get your routine. Same applies for hesperidin, which is also being done from your orange peel. But take a case of flavonoids which are present in a very minuscule or trace level. Say, for example, people, those who are trying to isolate isoflavones, that is genistein, diadzine from soy, the percentages are really less. In that case, you have to, or you don't have any other option but to use chromatography, that is your column chromatography, or preparative HPLC for separation of such compounds. We have a question also uh, asking to elaborate the difference between resins and resins in the discussion forum. So, resins encompasses a broad class of compounds. Now, this broad class of compounds, if you remember, include acid resins, resinotanols, glycosides, and so on. And one subcategory of RESIN, one subcategory of resin is resins, RESENs. Now, resins are considered to be the most inert molecules, like your rubber. You acidify them, you basify them, they are very proof, or mean they are very resilient. They won't deteriorate or they won't really transform. In certain cases, many a time oxygenation is also seen, but deterioration is not seen. So the answer to these questions are resins, RESENES, is a subcategory of resins, RESINS. And in this case, what is done is they are the subcategory of resins which are resilient to digestion by acids or alkalis, and they remain insoluble in most of the solvents owing to their high molecular weight. So if there are no further questions, we'll close the sessions for the day. So thank you everyone for joining in this session and keep learning. Thank you.